And so to welcome our next speaker, we have Markus Rothkötter from University Magdeburg of the Faculty of Computer Science. So welcome on stage. Here you go.
Thanks.
Yes. Thank
Perfect. You. Okay. So, as already said, I'm Markus and I'm from the University of Magdeburg and I'm working at the chair of computational intelligence. And the project I'm in is about developing the next generation of mobile networks. So 6G, currently we are at 5G, or it is rolled out. And our focus is how can we integrate AI in those networks. And my personal research focus is on the design patterns needed for those multi-objective optimization and decision making. So I assume that not all of you have heard about multi-objective optimization. So imagine you want to have it all, but you can't. You have to decide on a trade-off. And this is the basis for decision making. So what will we learn today? First of all, you will notice how decision making works, and I will illustrate it for a little hike to the mountains. Secondly, I'm trying to identify the set screws for designing such algorithms, and you will get to know why diamonds can be quite useful in looking for these set screws. Then we are looking at measures that can judge the efficiency of our set screws, and you will learn about colorful heat maps and how they aid in deciding about the efficiency. And last but not least, I will try to put it into perspective why we need a perspective on a whole system incorporating multiple different views. So starting with decision making, what is a decision? Basically, a decision is the selection between alternatives with conflicting objectives. Imagine you want to reach the top of a mountain, but you have two objectives. First, you want to spend the minimal effort. And second, you want to have the best photo spots. We have three possible alternatives. First of all, cable car, second is the hike, and last but not least, you will climb. And there are different objective values. So taking the cable car doesn't mean putting in any effort for you. But a cable car is not the perfect photo spot. Hiking means you are near to the ground, you will see some beautiful nature, but it is a little more effort. And climbing means a lot of effort, but you will have spectacular photos. Selecting one of these alternatives means you lose the others. So we have to think about solutions in a way, do they really fulfill the purpose we are trying to use them for? So if there's no climbing gear available, we just have few feasible solutions, which means most of our problems that we consider for decision-making optimization have constraints. And in this case, if there's no climbing gear, going for a climb is rather infeasible. So we have objectives, we have constraints, and the last thing about decision-making are the preferences. And one of the key takeaways of yesterday was, AI won't solve any problem. In the end, it will be a human decision. And this is where we put in the user. We have a human-centric approach that we say we present the options generated by AI to a user, and this user has personal preferences and chooses one option. And in this way, we have two benefits. First of all, we only devote the resources needed for a very specific result. And secondly, we can understand the implications of trade-offs. So when we say we want better photos, we have to put in more effort. Keep the example of the mountain in mind. We'll come back to it later with respect to sustainability. But the bottom line of this type of optimization is we have an outcome which can aid sustainability, but what about the process of generating these options? So on the one hand, we have our tailored solution, which minimizes excess in the actual realization, but we use AI or computational intelligence to generate those solutions, and by design, most of them will be trashed because we present a bunch of solutions and only one will be selected. And this means we have a potential for applying AI for sustainability, but there's a huge challenge in sustainability of AI when we generate this solution. So we have to come up with reasonable design decisions that allow us to generate good design of AI algorithms. But what are the set screws concerning this type of AI, multi-objective optimization? In order to derive those, I would like to introduce a standard model of product design so that we can review the process of designing an algorithm with a model that is normally used to design, for example, hardware products. We have two different spaces. First, the problem space. We want to understand what is the actual thing we want to build. And then we have the solution space. How do we build this thing right? And if we apply this to multi-objective optimization, we have a very complex search problem on the one hand, which is a highly dimensional search space. And some of these solutions in this space are optimal. And we want to find these and have to create a search algorithm. So in our problem space, we have to capture this problem in a mathematical formalization, which is the first and fundamental step everything else builds on. And for multi-objective optimization, this means defining objectives, defining constraints, and deciding on the incorporation of preferences. Then comes the actual algorithm. So the second step is the solution implementation. So we select the algorithm, we design some operators, and we optimize the runtime. Currently, we are quite good at stuff like runtime optimization, but even if we have the most efficient algorithm, if we run on the wrong problem, it's not sustainable. So we have to build the right thing first. And therefore, the big question is, how do we check that we are building the right thing, which is therefore inherently efficient? And this means, for multi-objective optimization, we want to minimize the effort on non-conflicting objectives, constraint handling, and irrelevant preferences. So now, for the remaining minutes, I have 3 small examples for these. And as I said, efficiency includes optimizing only objectives with conflicts. This is how an actual result set would look like after you've run an optimization. And it's a very busy slide. So let's just focus on a subset. We have 2 different results for different objectives. And here we see a trend line with a negative correlation between those objectives. So there's conflict potential. We are spending our energy on investigating trade-offs. Sounds good. On the left side, we have a trend line with a positive correlation. So there's less conflict potential. We do not have to investigate different trade-offs. So using AI or population-based approaches here is just a waste of computational power. So first, can we define our objectives in a way that only those who are conflicting are covered? This would be an interesting question that every developer would have to cover. Secondly, efficiency includes minimizing the effort for constraint handling. There are methods to circumvent the emergence of infeasible solutions, but not for all use cases. So normally we have our landscape where we search for a solution, and there are regions with infeasible solutions. So we spend energy on excluding these. But sometimes we spend so much energy that we do not even reach the actual point where we get because we blocked it. We simply blocked the way. And therefore, what about the idea of having a constraint handling which is tied to the course of evolution in, for example, a genetic algorithm, so that based on the evolution, we tighten our constraint or loosen them so that we won't spend energy on too tight constraint handling. And last but not least, the focus on relevant configurations. Here again is our busy result set, but this time I included a little legend, which shows that different colors show different preference configurations. And if we do again some analysis of correlations, we have a nice heat map. Orange means conflicts, blue means no conflicts, and the number 1 is the example from the previous slides. We have the indicator 2, which indicates conflict potential, which is sensitive to the preferences. So from seeing these results, there's the question, can we design an optimization that is modular and divides subproblems for the specific preference groups only? So this brings me to my last point, having a real-world perspective on defining these systems, because all those questions were about system design. They were not about algorithm design. And as I work in mobile networks, I've brought a small, very simplified example of a mobile network. We have different devices and different sizes of devices, and we have two parties interested in optimizing this. We have the infrastructure optimizer and we have the network operator. Infrastructure optimizer says, okay, let's get rid of the active cells, reduce them. Sounds good. Reduction is always good. Then the network operator says, well, seeing it from the technical perspective of a network operator, it's better to just switch off the big cells because multiple small cells are way more efficient than one big cell. Then the infrastructure optimizer says, well, we cannot place them everywhere. Then the network operator says, well, but the big stations are the expensive ones. They need the grid energy. And then there's a third party saying, well, I don't care about consumption as long as it is green energy. So you see, coming up with a good system model means we have to get the ingredients for our optimization right. And therefore we need a common ground of understanding and a shared perspective on our system. And if you remember the example from the beginning with the trip to the mountains, where was sustainability? Having the option of a cable car is not really sustainable at all if we consider the impact on the environment. So having the perspective of sustainability simply was missing in that optimization problem. So we as a developer have to make sure that we incorporate that perspective. So thanks for your attention, and I'm open for questions.
So thank you for this journey. You really took us along this hike. You have several minutes left. So I was wondering if you would like to elaborate on one or two slides, especially one I think was what I would have a question immediately to, the constraints blocking the way to sustainability, since you have we didn't even reach your 5 minutes call, so you can maybe
yeah, I hope that we have some time for discussion, and therefore
we can also jump into discussions, but maybe this is also interesting some people from the audience. Yeah.
So basically, imagine you have a problem where you want to reach the other side of a river. And you have to get there. And if there's no way to cross the river, you cannot get there. So a constraint handling mechanism in an algorithm would therefore be, for example, that we have something that blocks you from crossing that river because you cannot swim. But as evolution shows, over the course of time, we sometimes develop skills needed for solving certain tasks. But this means we have to go to the edge of the possible. So we have to test whether we can we can improve by failing just at the furthest point. And if our constraint handling is so hard that we do not reach that point, we cannot evolve beyond it. And therefore, just thinking about constraints in this yes or no way, or just in a punishment way, that if it is not feasible, we have to punish it, it may be an interesting idea to think about a constraint handling mechanism that is not only a decision, but also on a time scale tied to the evolution. So that in the beginning, we are way more flexible. And as we are flexible, we do not need to spend energy on constraint handling, because it will be not that beneficial for us.
Thank you. Are there, yes, we already see one question over there. Thank you.
Thank you very much for the very interesting talk. I'm from the healthcare sector, and we run into the problem of different optimal solutions. They're different from the perspective of the viewer, like for example from the radiologist perspective or from the developer's perspective. I want to ask if you could comment a bit more on how to solve these constraints and how that people think different about the optimal solution. What are your approaches there in your sector, for example?
So, as you said, there are multiple optimal solutions. The first thing is to make sure that everyone has understood that there is the potential for multiple optimal solutions. Because normally our notion of, for example, AI is I push a button, it runs, and I get a solution, and this is the solution. But different preferences require different solutions. So the first step is to make sure that we get to those optimal solutions. And then it's all about communication of those preferences. So how well can we negotiate the trade-offs? And this is often an incremental process. So you start with one set of solutions, and then you rule out the ones that are an absolute no-go for some of your participants, and then you can run the same optimization again, deriving new solutions within the narrowed scope. And continuing like that, in the end, of course, it will always be a decision that has to be made by a human, and it always has to be negotiated between different parties. But the issue of modeling fairness within those optimizations is also a closely related field.
Okay, Amy and Duke. Or Duke and Amy.
Yeah, I can go first. I'll take it. Thank you. So we already talked a little bit before your presentation, of course, because well, this is super interesting, and you sort of have an approach towards making these complex decisions, right? That are having multiple objectives. So I'm just going to ask the question we discussed a bit as well: is can you also deal in this with more of these fuzzy and conceptual contexts, like more certain values, whether they be sustainability or gender equality or all of those kinds of things? Would those values be able to be used as preferences or constraints in this sort of method, or do you need really hard mathematical concepts in order to be able to use this system or this approach?
Well, of course, most of the things depend on math, because we have to calculate how good a solution is to rank it within the algorithm and so on. But especially the more fuzzy objectives are often hardly to interpret from just a number. So an approach would be to, at least when I'm thinking about it, would be to come up with the comparison. Because if you see just a number without a reference, you don't understand it. But if you have multiple references that you compare, it doesn't really matter what the function is behind deriving those. You can understand the implications of choosing that. So an interesting point for research would be to find ways to illustrate the different options so that you can judge in the best way without bias.
Thank you. Thank you.
Yeah, thank you for. Hey, whoa. Thank you. This is also really interesting talk. I'm wondering, at one moment you said, I think it was when you were talking about the trade-offs. If there's no trade-offs there, no need to go further. If there is trade-offs, then...
When we have conflicts, then we have to find trade-offs. If there are no conflicts, well, we just go for the greedy solution and directly find the easy solution.
And then you had this one sentence after that where you said, you think that it's up to you as the developer, to have the responsibility to do these kinds of assessments, whatnot. So I'm wondering, because of all of the conversations that we've been having, and some people say, the responsibility on the developer or the tech company isn't enough, that we need policy to, make this, you have to. So I'm wondering if you can comment on that. Do you think that it's actually possible? Duke was saying in the place where he's working that people are starting to get this frustration, and so they have a certain level of motivation. Should we wait for that and wait for tech developers to feel the sense of responsibility, or do you think that we should force it upon them?
Well, it's a really difficult question, I think, and it's a very personal opinion. I think that, for example, the idea of this label, how much energy was consumed, for example, for reaching the results of that paper, would be an interesting mean to raise awareness. I'm not sure if raising the awareness will ultimately solve the problem, but it will be better than the state that we have now. And in general, I think, of course, the developer has some kind of responsibility, but we have to think about the fact that the problems we are solving have been unsolvable years ago. So we are always thinking about new stuff. And this means having a solution at all is already a huge gain. So it also puts a lot of a burden to the developers to say, well, not just get a solution, get it also right. So I think it depends on how long the research or the field or algorithms have evolved. So for the explorative first work, I would say, okay, we just test. But if it has already matured and we know it works, then we should definitely put some responsibilities on the developers too.
Fascinating. So sorry, are there more questions?
You can go on.
So that's really fascinating. So you would say that there's like phases. So at the exploratory phase, there doesn't need to be this requirement or this obligation to measure energy consumption. But then also, how would you define? And I know you probably just came up with this on the fly. But then, how do you define the exploratory phase versus something that's a more mature phase? I'm super curious about that. That's why I'm asking. We can also talk about it over coffee if you want. But.
It's interesting for many, I guess. Yeah,
it's true. I see a lot of things in phases, and we always have to base our judgment of a result in context of the phase where it developed. But narrowing it down to these indicators for a phase is really difficult. So I think there are multiple dimensions like time or widespread within use. So there are things that are around for quite a long time, but nobody uses them. So putting a big burden on those would just hamper research. If there's something that is, for example, transformer models, now the new thing that everyone wants to use, then it's a different phase. So I think indicators for phases have to be made up out of these different dimensions. But what the exact dimensions are is super hard to judge. And I'm not feeling as, clever enough for that.
That's cool. I was just pushing.
It's a difficult question, yeah. So if there are no more questions from the audience, thank you to both our wonderful speakers. And yeah, give one round of applause. And now it's time for lunch, so enjoy and see you after lunch again.